Hey there, this is the compound interest master sheet. It is one type, for the best I can do, it's basically one type of question for each of the variables. And I kind of want to apologize now because I realized I didn't leave a whole lot of room. So those of you that write big, sorry, let's get it done. What principal should be invested so it will compound to $13,000 in 5 years at 12% compounded quarterly? And I can see I stole these from somewhere else because the answer is already there for us. Now, what do we want? So P, nope, sorry, APIN. Okay. I could have written principal and things like that, but you know what? To make everything work, we're just going to put it all here. And you can clearly see what is given and what is wanted. 5 years. Quarterly, so times 4. So that's 20. My interest is 12% divided by 100. Remember, divide by 4. Divide by 100. Divide by 4. 0.03. And look right there. What principal? Okay, there you go. And so we'll compound to 13,000. That's our accrued amount, the amount at the end. A is equal to A times 1 plus I. Whoops. Plus I to the n. So 13,000 is the principal, which I don't know. 1 plus 0.03 to the 20th. 13,000 is equal to my principal, 1.03. I'm going to double check 1 0 there, 1 0 there. I've made a couple of mistakes making the videos by screwing up the number of zeros. All right, what's next? Yep, we're going to do that part. So 13,000 is equal to P 1.03. Exponent 20. 1.806. 111,235. I know I used to do it differently, but I can't figure out how to do that on this calculator. So I'm just writing it out. So that's what we're going to divide by. And I know I'm dividing by all of that, but I don't feel like writing all of that. So if we go 13,000 divide by 1.806,111,235, we have $7,198. Whoopsies, no, rounding too soon. 7.78 is equal to our principal. And ta-da, that's what it said up there too. That's nice. Okay, next one. Beth has $5,000 to invest. She deposits and gets 6.2% compounded weekly. Okay, so watch that, compounding weekly. What is the investment after 5 years? APIN. So she has, oh, let's just do weekly. 5 years. Times, we're going weekly, 52. 5 times 52 is 260. Okay, my interest is 6.2. Divide by 100. Divide by 52. 6.2. Divide by 100. Divide by 52. Oh, 0.000. 0.0192307. Tell me you appreciate when I normally make these work out pretty for you. And my principal is $5,000. So A is equal to P1 plus I to the N. A is equal to 5,000. That's my principal. 1, I'm going to be lazy and just write it. 0.0192307 to the 260. Fill in my calculator, plus 1. And there we go. And then exponent to 60. So A is equal to 5,000 times 1.363. Leave that on my calculator, times 5,000. Amount equals 6815.87 cents. And you'll find that if you don't carry all those decimals here, then you're not going to get that answer. You really do need to carry them to get the right amount of cents. All right, 2 more. Oh, kind of 3 more. Bert invested $5,000 in a savings bond. Okay, so we got $5,000, 4%, compounded annually. Using the rule of 72, estimate how long it will take. Remember, rule of 72, you start with 72, and you divide it by the interest. And that's all you do. 72 divided by 4, and I'm thinking it's 18, just like it says, 18 years. But the key is estimate. Okay, how long will it take? And we need to be able to show the work. So A, P, I, N. So we are looking for how long. So we actually don't know that part. Our interest is 4%. So 4 divided by 100 divided by 1, right? Annually. My principal is 5,000. And we want to know how long it will take to double. So what's missing is we just need to put that in as 10,000, and we're good to go. I'm going to do it again. I'm going to find my formula, because I know there's a special formula that we can use. Pardon me while I look for it. There it is. It's number 27. N is equal to the log A over P over log 1 plus I. So N is equal to A, which is 10,000. Oopsies, forgot the word log. That's important, you need that. 10,000 over 5,000 over log 1 point. Oh, I didn't even answer that one. 0.04. 0. No. Plus 0.0. N is equal to log of 2 over the log of 1.04. And remember, all you do is punch that in. So I'm going to go log 2 divide by, oh, where'd it go? Log 1.04, and we get 17.67 years. So the approximation or estimation that we made there is really pretty close. Remember, the rule of 72 works best if it is compounding annually. If it was compounding more quickly, then there might be a bit more of a difference. All right, last one. I have $50 and I want it to grow to $500 in 7 years. What is the interest rate? A, P, I, N. I have $50. I want it to grow. It's going to take 7 years and quarterly. Everything we need is there. 7 years times 4 is 28. My interest rate, I don't know, but I'm going to divide by 100 and divide by 4. I'm putting that in there so that I remember at the very end that I'm going to have to work backwards to get here. So I'm going to have to multiply by 4 and multiply by 100. I'm starting out with $50. I want to have 500. A is equal to P, 1 plus I, N. So 500 is equal to 50. 1 plus, oh, I don't know the I, to the 28. We need to get this by itself. So the only thing we can do right now is divide this side by 50, divide this side by 50. So 10 is equal to 1 plus I to the 28th. Now you could start guessing interest and see if it works, but that's just too much work. Remember, you're going to do the 1 over 28. You're going to use the reciprocal exponent, which is pretty heady stuff. And when you do that, this part disappears, and I'm going to have 1 plus I. And over here, remember how that works? It's 10. And then we're going to use exponent. And I'm going to use my brackets. So bracket 1 divided by 28. Close my brackets. Eventually that's what that says, and equals 1.0857. Okay, we want I by itself, so I'm going to go minus 1, minus 1. So 0.0857, and I just randomly rounded to that. And that's going to be I, but that is per quarter. So we want to and as a decimal, so we want to multiply by 100 and multiply by 4. So times, whoopsies, 100. Oops, messed that up, divide by 100. I forgot to subtract 1. There. Times 100 times 4. All right, 34.28%. That seems really high, but I'm basically wanting it to increase by a factor of 10 or double several times to get there. So a high percentage is excellent. All right, end of the video.